And welcome to our Facebook Live with Paul Newman, who is the BP Professor of Information Engineering at the University of Oxford. He also heads up the Oxford Robotics Institute within the Department of Engineering Science, working on mobile autonomy, developing machines and robots which map, navigate through and understand their environments. So welcome, Paul. Thank you very much for joining us today. We're going to be talking about the future of cars, and you're kind of stood in front of one, so tell us a bit more.
So this is one of our research vehicles at the ORI, the Oxford Robotics Institute, and we built it to try and have a look at what's the horizon of self-driving car technology. So we've got a long heritage in mobile autonomy. We have driverless cars out around the streets of Oxford and London and all around the UK and California, but we built this vehicle to think, well, what's going to be happening in 5 years? What's missing? What's really hard? And sort of an example, we've just come back from a trip to Iceland, where we've taken an off-road vehicle in places that normal autonomous car technology just can't work. So it's pretty cool when you get a text saying we're just going down the side of a volcano, we'll call you back. And we've taken one of these vehicles out there. So this vehicle's equipped with a ridiculous number of cameras, far more than you would get on a normal automotive car. Radar and some lasers. And I'm particularly getting interested in the role of radar. I think we've missed it. I think that that automotive radar's great for that task if there's a car in front, but it's a far bigger picture of what modern radar can do. And so one of the things we took them out to Iceland is where the snow's so hard that you can't see anything and it's pitch black, and you might see a bit of the northern lights if the clouds broke. So I'm really interested now in the ORI of really the big off-roading stuff. I think we know how to do the on-road stuff. And that's going through a spin-out company, Oxbotica, and now how do you go from jungles and deserts and through glaciers and down volcanoes, because that's really the ultimate of can machines drive? Can they drive in all the places, not just on roads? And so that's where I'm going next.
Which is super exciting,
Isn't
I
it?
have to
I
say.
think it's really properly exciting.
But what I think people might be surprised to see is actually it looks like a car. Like it is a car, and
Well, yeah,
and
I mean,
you've
the
got
thing
loads
is
of
that
sensors.
People that make cars are quite good at making cars, right? So you should start with a car, because this is with our partner Jaguar Land Rover. And we have a partnership with them, and they donated this car, so we then fitted it out with all of the sensors that we could think about, and we're taking this into some quite difficult places. Yes, we're doing the urban driving as well. What happens if you peer out at the world with cameras at lots of different focal lengths? So not just one, but lots of different focal lengths. There's interesting things you can do around that. And yeah, we've equipped it with a computer that's buried behind the back there, and yes, there's a crazy amount of sensors on the top because we swapped those out, but you open the back and you could put my dog in there and it would look like a normal car.
So in the future, will you be sat behind the steering wheel still and just watching it? How does it work?
No, I mean, how can there be a world where for all time humans who are really bad at driving and make terrible mistakes will always have to be driving? That's not a world that I can imagine. So no, we won't always have that. For quite a long time we'll still be buying cars that have steering wheels in them. But I absolutely believe that we will look back at the times where we have the amount of maiming and accidents and costs that we have on the roads and pollution now and go, wow, I'm really glad that we have this technology, just like we look back at typing pools and go, wow, that looks just a really bad way of having to delete letters by typing the whole letter again. That looks really bad. Right? And it's going to be analogies like that.
And so I think
like that analogy. I can't like that. I haven't done that one before.
so I think people are watching it going, so I don't really understand, so I'm going to program in where I want to go into my car, get in the back, have a little rest, and you have that full trust.
Yes.
And the car will understand, I mean, for the future, will it mean less accidents and things like that?
It has to. So look, 80% of all accidents on the road are caused by human mistakes, and often that's inattention. Inattention is the single thing that a computer will never do. It has a superhuman ability to just do the same thing all the time and never get bored. It has no sense of ennui. So, and that's a human fallibility. So we do get distracted. We're generalists, but we do get distracted. And that single thing is what machines will never do. And there will be accidents, and obviously there's been an awful accident recently, and that's a tragedy. And it's awful. One of the things that I think about that, and have lots of thoughts about that, is that the difference between humans having accidents and machines having accidents is that humans have no way to share that and reduce the chances of other accidents because they had one themselves. So I had a driving accident, and it was my mistake. Okay. The next day I was really spooked because I thought, well, I don't think I'll drive any differently. I just made a mistake. I just did not see that van. I wasn't distracted. I thought I just made a human mistake and I didn't know what to do. And I certainly couldn't make my wife a better driver, or my family a better driver, or my sister or my dad a better driver. I wasn't able to do that. But autonomous vehicles, as they experience the world and the world challenges them, will be able to share that learning. And that's singularly different from what humans do, where we are singularly alone in the way that we make our mistakes. And that for me is a real motivator as that technology forever gets better. Whereas human driving plateaus. Machine driving will get better all the time because the machines talk to each other. It's a good thing.
So in the future, is your vision that the roads will just be full of autonomous cars and there'll be no humans driving cars?
Well, I think technology provides us with options. It doesn't force anything. I mean, there are those that say there'll come a time where you will have to have a special license not to be driven by a machine. That's a long way off. I mean, we'll see autonomous vehicles for transport in cities. I think this is fully autonomous transport where there is no steering wheel. Starting in small areas, we call it geofencing. So the vehicle knows where it is in the world and there's an area in which it will operate. And that's like a fancy bus. So to get your transport on a bus doesn't really come to your home. You maybe go to a place where the transport system is working and it's a fully autonomous system going around some areas in some cities, and over time that expands and gets bigger and bigger. And the reason I think it expands over time is that still the full driving problem of going from anywhere, any place to any other place, any time of day, whatever the weather, all the time, with kind of the performance that we have for your self-driving. I mean, you don't generally go, I think my car, I'm worried about getting to the airport because my car might break down. But these things are engineered to be epic. They just don't break down. And so if you had a vehicle that could not do all of the trips for you, and yet you bought it in the same way you would buy one of these vehicles to take you anywhere, to any place, any day, whatever the weather, and never worry about not making it, trying to replace that one for one with a technology that's still nascent, that's going to be quite some time coming. But you can imagine it in some cities as mobility as a service. And of course, you know, the driverless car thing is huge, but also driverless trucks, driverless ports, driverless warehouses, driverless farms, driverless mines, Mars. It's all the same thing. It's all the same technology. So you've got three questions. Where am I? What's around me? What should I do? You answer those questions and you hit those questions out of the park, all of these domains are available. And that, for me, is the core of the science and the engineering research that I do, answering those three questions, not specific to the roads, not specific to a mine, but the general capability of having a machine say, I can ingest sensor data, they're pictures from cameras, this laser data, it's radar, and I've got some memories of the world. And that's what I get in. Can I figure out where I am, what's around me, what those things mean to me around me? Is it a person walking? Is it a dog? Is it a hay bale blowing? Is it a bag that's empty on the ground? Is it a container I need to pick up? Is it a fracture in a mine? And then decide what to do because of that. And then do something that creates wealth or helps us or makes us safer, more productive. That's great. And I have the best job in the world because I get to work with just extraordinary people, both in the university and in the company, who write text files that when you put on a vehicle, the vehicle then behaves intelligently. And there's something about that I have found attractive since I was like 18 when I first started to program, that you can write a text file and it's a program. And now these days you feed that program with an enormous diet of data and something extraordinary happens, and then that vehicle starts to behave in a way you would want it to do as it's driving you around. And I put, people say, would you put your kid in your driverless car? And I did. And one of the best memories I have was my 8-year-old sitting in one of the cars that we built and waving as the thing just zoomed off. It was just the best thing. And I thought, she's going to grow up with this stuff going, I remember when that was nascent, but it's going to be in her lifetime for sure. It's going to be everywhere.
Okay, because that was my next question. Like, when will we see this happening in this exciting technology?
So that's a good question, but it's a common question, and it doesn't get answered by me saying, like, Wednesday the 15th of June 2021. Okay, there's not going to be a step change. There will be changes in gradient. Again, it comes out to this geofencing. You'll get, Waymo are operating in Phoenix. You get areas where you'll get this as a service. Now, there are some ports that are already fully autonomous and the vehicles are driving around, and there are some mines where there's a large degree of autonomy. So for me, it's a blending, and it's a blending of both the technology and the place. And I'm going to flip the question to say, we never really said, there's a whole bunch of dogs here. No, that's not, so that's odd. So we never really said, when will we have computers? That doesn't sound like a sensible question now, does it? What we say is, what's next in computing? And I think that's what we're going to talk about robotics. We're going to say, what's next in robotics? What the vehicle's going to be able to do next? What's next in machine learning? And there's a gradient, so there's not a sudden sort of step change. And I think that the duality with computing is quite a powerful one. It wasn't a day when suddenly we had computers, and it wasn't then done. It's never done. Every month there's something new and amazing about computing. Oh, I need that in my life. So I think that's a really good metaphor and simile for what we're talking about here.
And I know we are talking about driverless cars today, but I have to ask you about all the other exciting things you're doing. Like you did bring up, Mars and mining. I mean, tell me a bit about that.
Well, that's you see, here's the thing, right? So those are the same core questions. Where am I? What's around me? What should I do? So you've got a big mining vehicle, it needs to know where it is. And if it knows where it is and what's around it, and it needs to go and pick stuff up, then it knows what it needs to do. But it needs to do that by watching out for all the other people and the other vehicles that are in the mine. So it's the same thing. And the Mars mission, so we're lucky enough to some of the code that we wrote in the university is going to go on one of the Mars missions for a rover. That's great, isn't it? I mean that is exciting, and that's great for what a university should be doing. In terms of other stuff that's happening at the Oxford Robotics Institute, well, we've just started a big thread in legged robotics. So we've done wheels, okay? So Morris and Yanis, they're starting now the Dynamic Robotic Systems Lab, which is the leg lab, and so we're getting hold of vehicles now that will run and jump and walk because nature doesn't have any wheels. So that's the next thread. We're thinking about flying. And so we've got a project with White & Woods here, tracking the arrival of Ash dieback. So there's a lot of work that we can do with machines that know where they are, what's around them and what they should do, helping in other domains of science, so helping zoologists, plant scientists, and helping agriculture, and looking at mining and societal aspects about population growth, and where people are, what they're doing with their houses, all kinds of really extraordinary things that we can do. And then high-level planning as well. So how do we have machines that interact with the intentions of a human, so you could verbally say, I want you to be doing this, every week go and make sure this happens. So every week go and make sure this happens. How do you parse that down to actually a machine going somewhere and making sure that someone's okay or someone's moved? And so Nick Hawes is looking at that as well. My colleague Ingmar Posner, he's starting to look at some of the deeper questions in AI about representation and curriculum learning. So, to learn is to teach. So what's the syllabus that you should be giving a machine? How would you teach it to have the competency that you want? And starting to think about robotics arms for doing that. So we're having an absolute blast as we started as the Mobile Robotics Group, and now we've diluted that to the Oxford Robotics Institute. And Steve Kybert, he runs a platforms group, so we're very keen now on big, quite expansive experiments and field deployments. For me, it's always about field robotics. So this thing, going out to Iceland, going to the desert, big things that are ambitious. And why do we do that? It's because that's where it won't work. So I like in the university to stick the machines in places that actually, when the data comes back, I go, well, maybe that was a little bit hard. And looking at some of the data that came back from Iceland, from Andrea's team, it looks quite hard actually. So we're going to have a bit of a think about that, but we'll get that to go, and that's going to be exciting.
And you bring up Iceland, and I have to ask, so how does the sensors cope with weather and snow and rain?
Right. Well, so that's interesting, isn't it? Because in part I don't know. But no, I got a few good ideas, right? So obviously cameras in whiteout, pretty tricky. I have to say it was the best weather they've had in Iceland in 30 years. The snow was here, but anyway. So radar in particular doesn't get impeded by water. So working with a company called Navtech Radar from down the road, and they make a particular kind of radar at 77 gigahertz that has a particular ability to see straight through water, and so when there's dust and there's snow and there's rain, it sees with a completely different source of radiation. So I'm super interested in that as well, and then trying to get that to go in really some quite awkward terrain as well. So what I'd really love to do is to be able to do that. You know, we took the radar inside an old power station, in a forest, and on a lava field. I'd like to do that. Why? Because I think that forces us to think about, well, what's common about all of these problems, and some of that starts to get superhuman. Like, humans aren't always good at walking on glaciers and navigating. I mean, that is niche. I'm not proposing there's a big commercial need for glacier navigation, although there are a couple with our colleagues at Arctic Trucks. So yeah, that's where I'm at, and I'm pretty excited about all the opportunities that we have. There's a lot of things to do.
Yes, I can imagine. And what I think is exciting, and to let our audience know, is, you know, it's a lot of data, it's a lot of computer science. So if someone wants to get into this technology,
Program.
it's
just program. That's it. Program.
Program.
And then get stuck. Keep programming. Get unstuck. Program some more. Play with those languages. The brilliant thing about software is it's massless. To completely change the way your program works, it has no inertia. It's a text file. So and just pick off small problems and just have a go, refactor it, have a go, play. If you're interested in robotics, get a cheap computer, get a Raspberry Pi, get an Arduino, and plug it into something that moves. Try and get some real sensor data. Try and get a camera and just find lines. Just take a webcam and just try and find all the lines. Then try and find the edges of the road, or then try and find people and understand what's going on there. Sometimes I think that the simpler problem that you set yourself in computer science exposes the more fundamentals. I mean, I often have this case where I show someone the data that comes in from a camera is literally a stream of numbers. It's how many photons in a pixel in a period of time. And you just give them the list of numbers and say, what should I do next? And that's actually what the computer vision problem is, what this thing's doing. It gets a list of numbers and has to decide whether it's going to be hitting something if it doesn't take some course of correction. So I would advocate in getting into this, just pick the question that surely should be doable. I'm just looking up there as a picture of a college. Find all the squares in that picture. There are so many different kinds of squares on bricks and windows, and actually that simple problem is actually going to expose what's hard and what's really exciting about when you nail it in computer vision, for example, and programming. So just don't be afraid to get involved with a camera and a cheap piece of hardware and have a go.
Well, thank you for joining us. And if anybody's got any further questions, please put them in the comments box, and we'll get Paul to answer those later. But finally, Paul, I just want to say thank you very much for joining us, and we look forward to seeing you in the future. Thank you.
See you.